Hello everybody, Namaskar. So today we will study in lecture 12 the processing and preservation of fruits and vegetable by removal of water. The concepts which we will cover here in this lecture includes what are the stages of water or various types of water present in fruits and vegetable, then removal of water, how it is beneficial, calculation of moisture removal and drying time, factors affecting drying rate and its effect on products quality, evaporation, mass and energy balance, or boiling point rise and its effects on drying process, concentration process, and finally, we will also discuss some basic concepts of reverse osmosis, which is used for osmotic concentration and osmotic dehydration of fruits and vegetables. So, the different types of water which is present in the fruits and vegetable or such other commodities, you can see here in the picture as it is shown, it is bound water, unbound water, equilibrium moisture content and the free moisture. Bound water is the amount of moisture that exert vapor pressure less than the vapor pressure of the water at a given temperature, and you can see in the picture it is the bound moisture present in the commodity. Unbound water, that is it is the water that exerts equal pressure to the vapor pressure of water at a given temperature. Equilibrium moisture content is the moisture content, you can see here in this that figure EMC, the moisture content which is achieved by the product at a given temperature and relative humidity. And free moisture content is the amount of moisture in excess of EMC that can be evaporated at a given temperature and given relative humidity. So, if the EMC of a product XE is known for a particular fruits or vegetable at a certain drying condition, then the free moisture can be calculated from the equation X is equal to Xi minus Xe, where Xi is the initial moisture content of the commodity. Okay. Now, it is the free water or unbound water which gives the commodity its water activity. Okay. And in the earlier lecture also we have seen that how the water activity is related to the various reactions etc., and how it influences the stability of the products and microbial growth. Also here in this figure or in this table I have given you the minimum water activity at which the various microorganisms can grow in the fruit product like fruit syrup, brine fruits, dried fig, jam, molasses etc. Okay. So, in fact, it is the ratio of the water vapor of the food to the water vapor pressure of the pure water under the same conditions which is expressed as a water activity, and each microorganism has a critical AW below which it cannot grow, it cannot multiply. So, this is in the water removal process what we basically do, we try to lower down the water activity of the commodity so that the microorganism, enzymatic processes, other chemical reactions are suppressed. So, the beneficial of the removal of water, it is as can you see here, microbial deterioration is eliminated, there is a reduced rate of enzymatic and chemical reactions, reduced product mass and volume, efficient product transportation and storage, and often we get more convenient form of the product, that is the convenient to use. The water present in fruits and vegetables are generally for that matter any commodity is generally expressed either on the wet basis, that is WB, or on dry basis DB. So, water content WB X WB is equal to MW by MT multiplied by 100 or MW by MW plus MD multiplied by 100. Okay. So, this is the wet basis moisture content, and dry basis moisture content X dB can be calculated by equation MW by MD multiplied by 100, where this MW and MD are the weight of the water and bone dry matter, and MT is the total weight of the sample. Okay. Also, these equations x WB is equal to x dB divided by 100 plus x dB multiplied by 100, or x dB is equal to x WB divided by 100 minus x WB multiplied by 100. So, this gives these equations gives one can calculate. If you know that wet basis moisture content, you can calculate the moisture content on dry basis, and dry basis moisture content is always greater than the wet basis moisture content. Dry basis moisture content is mostly used in analysis of the dry data. There are moisture content can be evaluated in the food by various methods, like direct method like hot air oven method, vacuum oven, infrared moisture analyzer, or indirect method like electric resistance method, dielectric method, or various chemical methods are there which can be used to determine moisture content. Now, we can also, there are certain provisions using the mass balance or moisture balance etc. We can calculate the amount of the moisture to be removed. Suppose you know that initial moisture content of the commodity or fruit or vegetable which is being dried, and what will be the final moisture content xt, okay, which need to be kept. Then one can calculate by mass balance, like in the figure here you see that if x kg of the raw material is put into the dryer and the raw material has moisture content xf% wet basis, and from the after the drying process is over, m kg of the moisture is removed, which is that is the xm% wet basis total moisture percent, and that product which comes out of the dryer is P having xp% wet basis moisture. So, the mass balance equation F is equal to P plus m, or moisture balance F xf is equal to P xp plus xm m. This can be used to calculate, that is how much moisture one need to remove from the product. So, accordingly the drying condition and other things can be maintained, drying temperature and all those things. Okay. There are now let us see what are the different techniques which are used for removal of the moisture, because fruits and vegetables contain generally high amount of moisture. So, dehydration, that is removal of water to form final product as a solid, that is the after drying the material dried product will be obtained in the solid form, or evaporation can be used, which is a removal of water while retaining the liquid condition or concentration for the two. So, you can say that for concentration of the commodities, or reverse osmosis which can be used for removal of moisture, and for either by osmotic dehydration or concentrating the food material. It is normally a non-thermal process and results in better product quality. So, let us drying and dehydration. Okay. Obviously, drying is as you can see here in this figure, drying is a complex process involving simultaneous heat and mass transfer, that is the material kept in the drying chamber where heat is supplied, there is a heat transfer, and then from the material water vapor goes. So, it is the mass transfer. So, it is a simultaneous heat and mass transfer operation. It is mainly physical in nature and can result in desirable and undesirable physical and biochemical changes. So, the transfer of heat provide the necessary latent heat of vaporization, and movement of water or water vapor through the food material, and then away from it to affect the separation of water from the food. Okay. This is this figure we have just again tried to show that how when you are supplying the heat, how the moisture is moving from the within the material as well as from within the outside the material. Okay. So, heating medium provides latent heat of vaporization to the water inside the food cell to evaporate it, and the water vapors diffuse through a boundary film, and the air is carried away by the moving air. Okay. A region of lower water vapor gradient is established from the moist interior of the food to the dry air, and this gradient provides the driving force for water removal from the food. Okay. Also, there are movement of moisture in the interstitial space of the food cell, that is liquid movement by capillary force, diffusion of liquids caused by concentration gradient, or diffusion of liquid which are absorbed in layers at the surface of solid components of the food, or water vapor diffusion in air spaces within the food caused by vapor pressure gradient. So, these are the various ways by which water moves. Phases of the drying, you can say that depending upon the moisture content available in the material, its condition, etc., that there may be the drying may take into various phases, like initial warm up period. You can see the initial removal of moisture in the figure from A to B. This occurs as the product and the water within the product experience a slight temperature increase. Okay. Then comes it is followed by that this constant rate period. So, a significant reduction in moisture content occurs here during the constant rate period at a particular product temperature. Your temperature remains almost constant until the moisture content is lower down to XC, or that is critical moisture content, and after that it comes the falling rate period. That is the falling rate means as moisture content below the critical moisture content, the rate of the moisture removal with the time decreases. Okay. And there may be, depending upon the commodity, there may be one or more falling rate periods, that is C may be observed in any commodity. So, there are equations, that is in this slide I have given you the equations by which one can calculate drying time. So, drying time calculation, suppose in the constant rate period drying, that is here you can see what is the drying time. It can be given by MC is Xi minus Xc divided by Tc, where MC is the moisture removal rate during the constant drying rate period, or Xi Xc are the initial moisture content and critical moisture content, and Tc is the time for the that is the time for constant rate drying. So, the total, that is the thermal energy Q transferred to the product is given by Q is equal to H A T A minus T S, where H is the convective heat transfer coefficient, A is the surface area of the product, T A is the hot air temperature, and T S is the product surface temperature. When the thermal energy is used to cause a phase change of water at the product surface, then Q becomes MC H nu, where H nu is the latent heat of vaporization of the water. So, from these equations 1 and 2 and 3, from these three equations one can calculate the drying time T c, that is drying time during the constant drying rate period, that is T c is equal to lambda V x I minus x c divided by H A T I minus T A minus T S. This equation is given by which one can calculate the total drying time during the constant period. Similarly, one can in the falling rate period, you can see that in the falling rate period the equation is given that x minus x c divided by x c minus x e is equal to 8 by pi square exponential minus pi square d T f 4 d square c, where this small d is the characteristic dimensions of the commodity. Capital D is the effective moisture diffusivity. Okay. So, and this will depend, that is in the falling rate period, that is the shape of the product, whether it is the slab shape product or a spherical shape product or cylindrical shape product. In the slab shape product, the total drying time in the falling rate period T f is equal to 4 d c square by pi square d ln 8 by pi square x c minus x c divided by x minus x e. All right. So, and in the spherical shape, there is this d in the slab shape, it is the half thickness of the slab. When it is spherical shape, the equation remains same, so only you can see here 8, that is constant, it becomes 6, and in this case d, this dc is the radius of the sphere. For cylindrical shape product, again this is equation remains same, that is the 6 becomes 4 here in this case, and this pi square becomes beta square. So, the dc in this case is the radius of the cylinder, and beta is the first root of the zero order Bessel function equation. So, by this, depending upon the product geometry, one can calculate the T f. So, the total drying time of the commodity that is T will be is equal to Tc plus Tf, that is the constant rate drying time and falling rate drying time. So, total drying time T can be found out, this is the plus addition of Tc and Tf. Regarding process technology for the drying of fruits and vegetables, say you take the raw material that is clean, moisture free, clean, mature, disease and insect pest free fruits and vegetables. They are given to various obvious pre-treatment like cleaning, washing, cutting and other pre-treatment for blanching, etc. And then finally in the desired form, whether it is dried in the form of slabs or thickness or slices or cubes or whatever thing, okay, or ring. So, in the different form it is put into the dryer, and in the inside the dryer the conditions, heat etc., heat conditions etc., relative humidity, air velocity, all those things are maintained in proper requirement, and you can operate the dryer for desired period of time, remove the desired amount of moisture content, and once the dried product is obtained, it is packaged, okay, in appropriate materials. So, different types of dryers are drying, maybe conduction drying, which allows heat transfer from heating plate to directly on the material, and these types of dryers are tray dryer, drum dryer, etc. Then there will be convective drying, like use of hot air or ambient air or low temperature air for transfer of heat, like for example spray dryer, tunnel dryers, they work on this principle. Then there is also a radiation dryer, a radiation drying, that is which uses electromagnetic radiation such as radio waves or visible light etc. for removal of the moisture, like infrared self dryer. And the dielectric heating also can be used, that is which uses high frequency electric field like microwave dryer, radio frequency dryer. Then freeze drying, it involves freezing food rapidly and exposes food to high vacuum, that is water removed is here by sublimation, that is freeze dryer. And then vacuum drying, it uses of vacuum and conduction heat transfer, that is like vacuum drying. The different pre-treatments obviously, that like to prevent the fruit or vegetable from darkening during drying process, okay, there is various pre-treatment, particularly blanching to inactivate the enzymes etc. In the case of fruit, various methods used for pre-treating before it is put to the dryer is use of ascorbic acid solution, use of ascorbic acid for sugar solution, either dip or spray, dipping the fruits in honey or dipping the fruit in containing the fruit juices containing high vitamin, using syrup, that is sugar and corn, or using steam, or using sulfur dioxide solution, or treatment with sulfur fumes etc. So, these are the various pre-treatment meted out to the fruits before they are drying, in order to get the product color, appealing product color, and to inactivate enzymes etc. Similarly, for the vegetables, like there may be, they are generally blanched, either steam blanching or hot water blanching, and this blanching is done to inactivate the enzymes which are responsible for the enzymatic browning of the product. So, this blanching is advantageous because you get a better colored product, but sometimes this may result into that higher investment cost, particularly steam blanching. It needs some higher investment cost, or if the blanching process is not properly controlled, there may be this heat may cause some nutrient reduction. Now, let us see the various factors which influence the rate of the drying, like temperature. Increase in the temperature, drying rate will increase, and vice versa. Similarly, decrease in the relative humidity will cause decrease in the rate of the drying, vice versa. Similarly, air speed or velocity, product composition, product surface, or even characteristic dimensions of the product, they will all influence the this rate of the drying. Like for example, product composition, it affects the microwave, that is the moisture diffusibility, that is porous structure allows faster diffusion, while fat rich product lowers the rate of moisture diffusion. If product surface, higher the surface area, higher will be the rate of the drying. Okay. Similarly, that is effect of drying, there is also, it will influence the product color, like chlorophyll, it changes from the green to yellow because chlorophyll converted into pheophytins and pheopharbides, etc. Carotenoids may be oxidized, anthocyanins may be, although they are quite stable during the processing at low pH, but they get changed, their color gets changed by as a effect of heat. Betalains, they are very sensitive to pH and they are degraded to brown compound and neutral pH during the heating process. Similarly, Maillard reaction and enzymatic browning reactions, etc., they may also take, if the proper this enzymatic browning is earlier, this blanching is not effective, then it may take place. Maillard reaction, this is amino sugar reaction, they may cause the darkening of the product or even various flavor development in the product. Similarly, in the product quality attribute, like in the texture, collapse of structure will lead to the firmer texture and increased chewiness. Texture loss makes the shrunken shrivel. Even there may be shrinkage, like even increases proportionality with the volume of water removed. The material surface first undergoes the glass phase, keeping the material damp and rubbery towards the center. The outer material surface turns hard, which reduces volume and restricts the removal of moisture. Sometimes case hardening, etc., may also be there. Similarly, flavor changes or water activity changes. There may be, if the proper temperature and other conditions are not maintained, then nutrients also, that is micronutrients, particularly vitamins, minerals, etc., they may get destroyed. Okay. Now, after having drying, let us now study the evaporation. Okay. That is the evaporation, it is the removal of the moisture. All right. It is important operations generally employed in the concentration of juices, etc., in the fruits and vegetable processing industry. That is for preparation of paste, puri, etc., like for example tomato juice. For long term storage, it is juice is converted into paste or puri of higher total solids, maybe 30-35% total solids. Okay. So, obviously, that is aim also here is that, like what you are getting advantage in the drying, the similar advantage here you are getting in the concentration process also. Only difference is that here little bulk may be more, because you are not removing completely the moisture content, all free moisture. In the drying or dehydration process, all free moisture present is generally removed, you get a solid product. And here only desired level, because the concentration you have, that the viscosity of the generally material becomes a limiting factor, that is up to what level you should go for the final concentration. Concentration is normally done in a evaporator, like here it is a schematic of the evaporator is given. The main components of evaporator are evaporation chamber, which holds the liquid product under vacuum. There is a heat exchanger which transfers the heat from low pressure steam to the product, and finally condenser sucks the vapor from the evaporation chamber. And the same thing which you have seen in the dryer, similar thing, that is the feed F kg is entering the evaporator and V kg of vapor is going out, you are getting C kg of the concentrate. Then amount of water removed one can calculate here by mass balance or energy balance or that thing. So, now the vapor which is going out from the product, if it is discarded without further utilizing this inherent heat, then the vapor system or evaporator system is called single effect evaporator. If the vapors are reused, that is vapors which are coming out, if they are collected and sent to the another evaporator unit, then that evaporator is called a multiple effect evaporator. So, the calculation of the removal of moisture from the evaporator, as I told you, that is here also, like you have done in the case of drying, you can do here in this also. The moisture balance F is equal to C plus B, or solid balance like F, XF is equal to C, XC, where F and C are the feed and concentrate with the water vaporized removed, or XF and XC represent the solid content in the feed and concentrate stream. Energy balance can be found out F HF plus SH is equal to C HC plus B HB plus CS HSC, where this HF, HS, SC, HB and HSC represent enthalpy content of the feed, steam, concentrate, vapor and condensate stream. CS is the steam condensate and Xf and Xc represent the solid content in the feed and concentrated stream. So, for the feed and the concentrate, the liquid stream, H is equal to Cp delta T, where Cp is the specific heat content Kj per kg K, and delta T is the temperature difference. So, for vapor stream, H is the latent heat of vaporization obtained through, which is generally obtained through steam table. So, one can also calculate the heat transfer and steam economy, that is rate of heat transfer through the heat exchanger to the product is given as Q is equal to UA Ts minus Tp, or is equal to S Hs minus Cs Hc. Q is the rate of heat transfer, U is the overall heat transfer coefficient, and A is the area of the heat exchanger. The steam economy is given by the B by S. Okay. That is the term is the ratio of the rate of mass of water vapor produced from the liquid feed per unit rate of the steam consumed. That is how much vapor, water vapor has been obtained per unit steam consumed, that gives steam economy. So, for single effect evaporators, steam economy value is generally close to 1. For multiple effect evaporator, steam economy value is more than 1. Okay. Now, the importance of boiling point in the evaporation, you know that very well, that is this means that when there is a liquid like fruit juices, water boils at 100 degrees Celsius, but in the if the water there are dissolved solids present, then there is a elevation of the increase in the boiling point. The presence of solid in the liquid increases the boiling point. Okay. Okay. That is means that the lower the pressure, lower the boiling temperature. So, increase in the boiling point is proportional to the amount of dissolved solid present in it. Okay. So, this by that boiling point elevation, the boiling point of liquid, the temperature at which the vapor pressure of the liquid is equal to the pressure exerted on the liquid by the surrounding atmosphere. Okay. So, this if benefits, one can get the benefits of vacuum in the presence of vacuum inside evaporator chamber causes the temperature difference between the steam and the product, and product boils at a low temperature with minimum heat damage. Okay. And for fruit juices etc., boiling point increase of the sucrose liquors is frequently applied, and it is always beneficial as far as the product quality is concerned. Boiling point elevation, you can see here in this figure, there is a linear relationship. Okay. That is boiling point elevation of a solution is defined as the increase in the boiling point over that of the pure water at a given pressure, and a simple method to estimate boiling point elevation is the use of Durang's rule. The Durang rule states that there is a linear relationship exists between the boiling point temperature of the solution and the boiling point temperature of the water at the same pressure. Okay. So, after now we have studied, seen the basic concepts of drying and concentration. Now, another important method of removal of water, particularly during fruits and vegetables, it is done with the reverse osmosis. Reverse osmosis is a process which uses a membrane under pressure to separate relatively pure water or the solvent from a less pure solution. So, when two aqueous solutions of different concentrations are separated by a semi-permeable membrane, water passes through the membrane in the direction of the more concentrated solution as a result of osmotic pressure, and that is called osmosis. So, when if the pressure is encountered and if this more than the osmotic pressure, then the concentration of the flow can be reversed, and that is the reverse osmosis. And this method is used for making even sweet pickles, where the fruit pieces etc., they are put into the concentrated sugar solutions, and so there is a osmosis, diffusion of the water from the sugar diffuses inside the cell of the fruit, and the water from the inside cell it goes out. So, water is removed and we get a firmer texture which has a more sugar content, and similarly this is a membrane concentration is also dilute juice is flowing over the membrane surface. So, the water is coming out and you get the concentrated juice. Okay, membranes have no pores, and movement of the water molecule is by the diffusion and not by juice liquid flow. So, water molecules dissolve at a one phase of a dense polymer layer in the membrane, and they are transported through it by diffusion and then removal from the other phase. In fact, this is a very emerging technology for the concentration of the fruit juices, etc. Okay, in our laboratory, we have used this membrane technology for the preparation of shelf life extension of the sugarcane juice, but industrially this is a very, very feasible process which can be prepared because there is no involvement of heat, no phase change. So, the quality of the product, the concentrate, generally it is often it is good. So, it is attainment of high quality product due to low temperature operation, resulting in the maintenance of nutritional, aroma and flavor compounds, lower energy consumption, use of compact installation and easy operations. However, it also this has certain disadvantages like lower output compared to the thermal evaporation and needs higher operating pressure here. Okay. So, now I will summarize this lecture by saying that drying and dehydration significantly affect the quality of the dried product. Water from the fruits and vegetable is reduced to equilibrium moisture content as a set atmosphere, that is temperature and relative humidity. Evaporation removes the water from the dilute liquid to make it concentrated, reducing pressure in evaporation chamber. The boiling point can be reduced and making the process more economical with less damage to the product quality. Even you can cause by reducing the pressure, one can cause the boiling of the liquid at a lower temperature. Okay. Reverse osmosis is a non-thermal process. It removes water and yields high quality concentrated or dehydrated fruits and vegetables, and all of these operations reduce the bulkiness of the product, that is weight and the volume, and they lengthen the shelf life, and if the process conditions are properly maintained, it also gives a good quality product. However, particularly during drying, conductive drying, etc., that rehydration, because of the time constraint we have not taken here the rehydration, but the drying process parameters should be maintained in such a way, so that the rehydration is better, because the completely dehydrated product, bone dried product, their consumption they need to be rehydrated. So, they should have a good water absorption capacity, etc. So, there are various methods also. This altogether different methods, and I will recommend you that at least you should read that something about the rehydration as well. So, these are the references which are used in this lecture. Thank you very much.